This is a video that explains how you would make this box plot here, okay? So how to make a box plot, which is what this is. So this box plot is made out of this data. So this is for the temperatures of patients who tested positive for COVID in degrees Fahrenheit, and this is made up data, so it's not real. All right, so let's say I see all these numbers over here. And that's a lot of numbers. So it's very hard for me to look at it and really be able to analyze it or say anything about it. It basically looks too complicated. So we want to simplify it and look at less numbers, okay? So we're going to find 5 numbers that help us to organize all this data, okay? The first number that we're going to look at is the minimum. So look at these numbers and say, what is the smallest number on the list? Well, if I have it all in order, which I do, I can find the smallest. So this is called the minimum. So that is going to be on my box plot. That's the one number. Now the 5th number is the maximum, and I'm skipping the other ones because they're harder, and so why not do the easier one? So the maximum. So which of these numbers are the maximum? And at any point, remember, you can pause the video and see if you can find the right answer, and then restart the video. And so you should have the maximum picked out, and then restart the video to find out if you're right or wrong. The maximum number is 115. So that's going to be the 5th number. That's going to help us with our box plot, okay? The reason why that's going to help us with our box plot is, look at this. The minimum here was 95 and the maximum was 115. Look at this plot here. 95 right here, that's 95 on my number line. So the box plot always starts with the minimum number over here and goes up to the maximum over here. So if you write lines the minimum and the maximum was 115, then that's going to give you these two numbers over here, the beginning part and the end part of my box plot. Okay. Now for the other 3 numbers. A box plot divides all the data into 25% groups. So basically this is too much numbers. So we're going to divide them up into like this is 25% of the numbers, this is 25% of the numbers, this is 25% of the numbers, so that it's easier to look at. So we're grouping them. So box plot is a way to group the numbers. So I'm looking to group them into 25%, and the easiest 25 percentile is the 50th percentile, because I can just divide the numbers in half. So I'm going to count how many total numbers there are to find the middle number and divide by 2. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So there are 50 numbers total. So 50 numbers total. So half of 50 is 25. So that means there's going to be 25 numbers in the lower half of the numbers and 25 on the upper half. So see if you can count through these, pause the video, and find out where that line should be between the bottom 25 and the upper 25, okay? So I'm going to do that now if you've already figured that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So this is the lower 25. So the bottom 50% of the numbers goes up to 101 here, the second 101, and the top 50% of the numbers starts with the third 101 right there. So that means that the 50th percentile is between 101 and 101, which is just what's halfway between 101 and 101, it's just 101. So the 50th percentile number, or the middle number, is 101. So we call that the median, okay? So that's going to be an important number, so I'm going to write that down right here. So let's write that on a separate paper. So the median was right here, 101. So 101. That's also called the 50th percentile because it's in the middle and 50% of the numbers are below it and 50% of the numbers are above it. Another vocabulary word for the same thing is the the second quartile. The second quartile. And that's because it has 2 quarters below it. The first 25% and the next 25%. And a quartile means quarter. So second quartile means that there's 2 quarters below this number, okay? So 101 is the 50th percentile number, and the second quartile. It's all the same thing. These 3 words mean the same thing, okay? We just usually say median and not the other 2. All right, so that's the median. Now, the other number we need to know is we need to cut this 50% into half again so that there's 25% below and 25%, the next 25%. So there were 25 numbers here, so I'm going to do 25 divided by 2. And you should figure that out and pause the video and then unpause it and find out it's 12.5. That means that there are 12 numbers below the first 25%, 12 numbers above, and then there's this 0.5 of a number on either side. So there's 12 and 12 is 24, and then there's one number in the middle. That exact number is going to end up being the 25th percent number, okay? So I'm going to count up and see if you can circle the 25th percent number on your paper or write it down before you restart the video. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then that means this is the 13th number. This number right here is going to be my 25th percentile or my first quartile. So that number is the 25th percent because it's a quarter of the numbers, and then a quarter of the numbers are up here. So if I count, there should be 12 up to this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's right. So that's my 25th percentile number. We call that number, which was 99. See if you can remember what I called it just a second ago. We call it the 25th percentile number. We also call it, which quartile do you think this is going to be? If you said first quartile, you're right, because the first quarter of numbers is below this number. So the first quarter of numbers is from here to here. The second quarter of numbers is from here to here, going all the way to the 50th percentile. Now I need to find, so this is 25% of the numbers and then 50% of the numbers, and then now I need to find 75%, which is halfway between here and here. So halfway between these 25 up here is still going to be 12.5, so I'm going to find 12 numbers, and then I'm going to go to this middle one, the 13th one, and that will be my 75th percentile. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the 13th number. So that is going to be my 75th percentile number. Okay. So see if you can figure out 103 is called what vocabulary word? What is one word for this number? You can pause if you need, and then you should have written 75th percentile number. What's the other word for it? Blank quartile. See if you can figure out what goes in there. Well, this was the first quartile. The median was the second quartile. So this one is the third one. So we call it the third quartile because there are 3/4 of the numbers below it. And that's going to be 103. And these 2 words mean the same thing. All right. I now have 5 numbers. The minimum, the 25th percentile number, which is 99. Second percentile number, which is 105, the 50th percentile number, excuse me. The 75th percentile number, which is 103, and then the maximum, which was the 5th number. Those 5 numbers are the points that made up that grid that we saw before. So we already labeled the minimum and the maximum. Notice that the 25th percentile number was 99, and this line is right before 100 because it's at 99. The 50th percentile number, or the median, was at 101. That's why this line is right here at 101. So this line here is the 25th percentile. This is the 50th percentile, and this is which number? That's at 103. It's called the, see if you can pause and find out, that it is the third quartile, or the 75th percentile. Okay? So when you make your box plot, you have these 5 lines, 1, 2, 3, 4, 5, and you basically make a line from the beginning to the end. So a line goes through the whole thing. However, you make a box in the middle because the middle 50 percentile is the most important one. And that's why we make them nice and big looking. So we make boxes around them because these are the more important ones. So that's how you make a box plot. I'm going to explain this box part a little bit more now. So a lot of times when we make decisions, we try and cover as many people as possible, but it's just not usually economical to fit every single thing in. So we can't usually cover the minimum to the maximum. I'll give you a good example. Doors. Doors, if you made a door that was the proper size for the shortest person or shortest people, those are like little babies, so that they could reach the knob, then it would be very inconvenient for most people. Likewise, if you made them tall enough for somebody who's 9 feet tall and like in the NBA, then it's going to be very inconvenient for most of us who are half their height. So we can't make a door that's convenient for every single person. So what we usually try to do is find something that's going to cover the middle 50%. Okay, so that's why. So then what's more important than these inch numbers when we're making things in mass quantities is really the middle 50%. What's really convenient for most people, and then the smallest people can sort of handle that door, and the tallest people can sort of handle that door, even though it's not the most convenient for them. So when you find out this middle, the 25th percentile, the 50th percentile, and the 75th percentile, that group right there, that box ends up covering how many people have to be included in your group of people that you make a door convenient for, the people you make a house convenient for, like how tall a counter is, how big chairs are. You're covering this group right here. And that's why we put them in a box. And then we just extend this to say, well, these people exist. We would like to make sure that they can use it, or just know that they exist so that we can create extra products for them. But this is what the main product is going to have to be good for right here, these people right here. Okay, now in this case it's temperature, so it's like 99 degrees to 103 degrees. So we're going to have to find medication that's good for this group right here, because that's the middle 50%. And then we're going to have to make separate products for these people at the ends in terms of what kinds of things are going to help them to get better. And that is why a box plot is useful.